the word similar mean in math? In general. The same what? They're proportional, but are they the same everything? No, the same shape, but not the same size. So congruent means same size, same shape. What is the symbol that we've been doing for congruent this year? The equal sign with the squiggly, or it is called a tilde. So that squiggly part means same shape. The equal part means same size, which is what congruent is. Do y'all agree with that? Similar just means same size. So it is just the tilde by itself. No, I'm sorry, I lied to you. Same shape. And that's why whenever you have equal signs means what size is it? The same size. The tilde is the same shape. So, same size. The tilde means same shape. So if two figures are similar, then their sides are proportional, meaning when you divide them, you get the same number. And their angles are congruent. For similar figures, the sides are proportional, meaning when you divide them, you get the same answer. But their angles are congruent, meaning, do y'all agree I have two similar quadrilaterals right here? Are their sides the same? No, I'm going to prove they're proportional in just a second. But what about their angles? What is this angle right here? Do you agree both of these angles are the same? So, I have KIDS and GOAT. What goes with G? Okay. What goes with O? What goes with A? And what goes with T? So, goat is similar to kids. Are they congruent? Are they the exact same? No, they're just similar, which is why it has just the tilde. Angle S is similar to what? Angle T. Really, they're congruent. Can y'all put the equal sign underneath them? Angles are congruent. But what is the measure of angle D? How come y'all didn't tell me it's A? And whenever we have the equal sign, what do we know? It's a number. I want a number. So y'all are right. Angle D goes with A, and A is 135 degrees. KI over GO equals what? If you have highlighters, if you want to go grab highlighters, you can. I'm going to use them right here. It's an equal sign. So what do I want here? A number. How long is KI? 6. What about GO? How long is GO? Count again. 12. And what is 6 divided by 12? So KI over GO, it's half its size. What about KS over GT? How long is KS? 2. How long is GT? And what is 2 divided by 4? Be careful. 2 divided by 4. 1/2. Last but not least, we have DS and AT. Count them. How long is DS and AT? Now, a lot of y'all saw the 4, and what did you automatically, without counting, think the bottom was going to be? 8. That's if they're similar. But what if this was 7? Then these would not be the same, and it would not be similar. They have to all be the same in order for these shapes to be similar. So this proves they're similar because they're all proportional. They're the same fraction. What questions do I have? Okay, what we just did without me even telling you is we just found the scale factor. Do you agree that kids is half the size of goats? By the way, did you know a baby goat is called a kid? Like a baby dog is called a puppy. A baby cat is a kitten. A baby goat is a kid. Anyways, scale factor. A scale factor is a ratio that describes the size change from the pre-image to the image. I'm sure everybody in here has seen or played with a Hot Wheel before. What came first, the car or the Hot Wheel? The car. And so what Hot Wheels does is they have a scale factor of 1 to 64, and they shrink down the dimensions of the car to create a Hot Wheel. That is a situation where scale factor comes into play. Can anybody think of another situation where we use or see scale factor every single day? Louder? Architecture. They're building onto Jersey Village right now, right? They hopefully, I know they did, because they had to prove it to Wiley and the district, but the contractors had to show a blueprint, right? I'm sure now blueprints are more digital than they were back in the day where they had to draw them, but is the blueprint they show them the exact same size as what they're building over here? No, they have a shrunk down version of whatever they're building over there. All right, what else? Where else do we use scale factor or see scale factor used? Figurine models? Absolutely. Y'all, look at what you're wearing. Literally everything that you are wearing is a scale factor of something, right? Because we all wear different sizes. The coats we wear, the shirts we wear, the shoes that we have on. Don't you agree those are all scale factors? They have to use scale factor to create them. So clothes are a big area we use scale factor. So now here's how we find scale factor. You are going to take your image, write this down please, and divide it by your pre-image. Sometimes they will be labeled. Sometimes they will not. They will not. So I also want you to know you will take your second over the first. If nothing is labeled, then you take the second thing over the first. Or what I'm going to use is new over old. This is the one I'm going to use most. And you divide and get a number. Xavier, write this down. Min, shut your computer. So if I have a scale factor bigger than 1, if I multiply something by bigger than 1, what is going to happen to that? If I multiply something by 10, by 18, by 2, it's going to get larger. It is going to enlarge. What if I have a scale factor that's bigger than 0 but less than 1? Like 1/2, 1/4, 1/32. It will shrink or reduce. It will be a reduction. You can put shrink. I have no problem with shrink. I have no problem with gets bigger. Like, that's fine. What about if it's equal to 1? What if my scale factor is 1? Stays the same, which is congruent. If your scale factor is 1, multiplying by 1 keeps it exactly the same. Last but not least, a negative scale factor. A negative scale factor is going to actually do two things. It's going to do one of the above and flip, or we like to say rotate 180 degrees. If you have a negative scale factor, you are doing two things. So I'm going to give you about 1 minute. I would like you to describe what each of these scale factors does to a picture. Juliana? All right, 2/3. What is 2/3 going to do to your picture? Reduction or shrink. What about 5/3? But it's a fraction. It's still bigger than 1. Do you agree 5/3 is greater than 1? So this is an enlargement. Be careful and don't assume just because it's a fraction that it is going to be a reduction. What about 1? Congruent. And finally, -1/4. It is going to rotate 180 degrees and what else? I think you said reduction. So the negative rotates it, the 1/4 shrinks it. What about -4? Rotate 180. And here's where people wanted to argue with me last period. And it is going to be an enlargement. But Miss Olivares, you said if it was less than 1, it's a reduction, but greater than 0. The negative is rotating 180. Then look at the number. What's the number? 4 is bigger than 1. It's an enlargement. Don't look at it -4 as the whole. Look at it each part. Open up your notes. We are going to do 5 examples and then we will be done with these. Okay? Can I change it? Alright, example number 2. How do we find scale factor? New over old. Everybody write that down, please. And by the way, I'm going to abbreviate scale factor SF. Are y'all okay with that? Bella, you with me over there? Okay. So, let's look at this first picture. Which one's my new? Which one's my old? So it's not always going to be the big one. It does happen to be the bigger one is my new. But why is this the new one? You have to look at the arrow. The arrow always points at the new. And my other one is my old. So to find my scale factor, are we okay? What is my new? What is my old? What is 6 divided by 4? 3 over 2 is my scale factor. And then check to make sure it makes sense. Is 3 over 2 an enlargement or a reduction? Did that actually enlarge? Then you probably got it right. Sometimes y'all mix them up and then it does, like, make sure it makes sense. 3 over 2 is bigger than 1, so it's an enlargement. All right, what about the next one? What is my old? What is my new? 7 is old. 2 is new. Why? The arrow. And then do new divided by old. What is 2 divided by 7? 2 divided by 7. We can't do anything else. And again, 2 over 7, is that an enlargement or a reduction? Did that actually reduce? So just make sure it makes sense. Because if you get a reduction and it got bigger, you did something wrong. Okay? I'm going to actually go out of order. Can everybody slide? Do y'all have that? Are y'all good? All right. Can everybody slide on over to number 4? No, number 5. Number 5. You can do the same thing with points with finding scale factor. And it does not matter. If your head's down, I need you to pick your head up, please. Pick it up off the desk. Thank you. It does not matter if you choose X or Y. You should get the same thing. If you don't, something's wrong. Okay? So, it says if the first point given is the pre-image or my old, what is the scale factor used to transform to the second point, the image or the new? Well, how do we find scale factor? Look at the multiplier, and if you don't know it, do new over old. If you're at 3,7, how do you get to 921? Multiply by 3, or you can just divide. What's 9 divided by 3? What's 21 divided by 7? So this scale factor is 3. -2, -1. How do I go to 4, 2? You either divide them if you need to. What's 4 divided by -2? Or some of y'all are just going to look at it and multiply and know. C's a little weird. How do you get from 2, 0 to 3, 0? Somebody told me add 1. No, we're multiplying here. What am I going to do since I don't know? Divide. New over old. What's my new? 3. What's my old? 2.
You'll need to unlock your iPhone first.
Thanks, Siri. And so my answer is 3 over 2. But what about the Y's? Yeah, hey, what's 0 times 3 halves? 0. So that, it would still work. Yeah. All right, last but not least, what about 4, 8 to -3, -6? New over old. -3 over 4 is my answer. Just divide them. Does that make sense? It's on your homework tonight. Okay? All right, let's go back to question 3. Question 3 says, a photographer enlarged a small picture to create a wall display. So here's the small picture. They want to create a bigger one on a wall. The enlargement was made using a scale of 1 inch equals 3/4 foot. That doesn't quite make sense, but we'll go with it. What is the scale factor used to enlarge the picture? And what would be the new dimensions in feet? So what are they going to multiply these by? 3/4 a foot. What is 3/4 a foot? 3/4. Well, how many inches are in feet? 12. So how do you get from 4 to 12? And what is 3 times 3? So this is basically saying 1 inch on this picture is going to be 9 inches here. You're going to So I'm going to multiply by what? 9. So how many inches are going to be here? 27 inches. And how many inches here? 45 inches. Let me restate that. For every 1 inch that's over here, that's going to represent 9 inches over here. And that's why we multiplied by what? 9. So let's answer the question. The first question says, what is the scale factor used? 9 inches. So I'm just going to write SF equals 9 inches. And then what would be the new dimensions in feet? If you put 45 and 27, that's wrong. Why? That's inches. I want to know the new dimensions in feet. What am I going to do to figure out how many feet this is? Divide by 12. And if I divide 45 divided by 12, can somebody tell me what that is?
3.75.
Say that again.
3.75.
3.75 inches. Nope. Not inches. Sorry. 3.75 feet. And what about the other side? When you divide that by 12, what'd you get? 2.25 feet. Anybody know how that actually translates to feet and inches? This would be 3 feet. How many inches? 9 inches. And what is 2.25 feet? 2 feet, 3 inches. You don't have to know that. That's just a little bit of extra information. What I boxed would be your answer. What part are we confused at? What can I help you understand? This one was a confusing question. Christiana, do you have any questions for me? You just don't know what to ask? Okay, do you get where we got the 9 inches from right here?
Yeah.
Because we just converted that to inches instead of feet. And then when I multiplied them, I just multiplied this times 9 and this times 9 to get the 27 and the 45. But I wanted the dimensions in feet, so what did I have to do? And so those are your just 2 answers. Yep. Any other questions? Armando, you write that down? Okay. Number 4. Now we're going to talk about dilations. You learned about dilations in middle school. What happens when you dilate your eyes at the eye doctor? Those of you that are blind like me, have you ever had that happen? What happens? Your eyes get super, super big. All right. Dilations do get bigger, but they can also get smaller. They're on a graph. And so a transformation whose pre-image and post-image are similar. On a graph, Which one's the pre-image? Which one is my old?
ABC.
The one with just the regular letters, ABC. Write old there. Nico, Xavier, write it down. And which one's my new one? We call those primes. A prime, B prime, and C prime. That lets you know that's the new one. Can you please write that down? And actually, sometimes we're going to have two pictures. In January, we're going to do this more. And it'll have two tick apostrophes. Two primes, double primes. Okay, what's the scale factor? Is this being enlarged or reduced? It is reduced by how much? How can you figure this out? Let's look at AC and A prime, C prime. What happens from one to the other? Let's do that to find the scale factor. So what is my new over my old? Be careful. New over old. 2, oh, sorry, is that what you said? Sorry, 2 over 6, which is? My scale factor is 1/3. Does everybody see how I got that, where I got that from? Okay. Can you please grab your badge? Grab your badge. To find the center of dilation, you are going to draw a line. You are going to use your badge and connect your A's. And draw a line through the entire graph. Then use your badge, connect your B's. And then connect your C's. Where do all of those lines pass through? Where's that at? The origin, 0, 0. So my center of dilation is the origin. Connect A with A prime, draw a line through it. B with B prime, draw a line through it. And C with C prime. We already did 5, right? So we're going to do the same thing on example 6. What goes with A? Connect them. What goes with B? W. Connect B and W. Draw a line through them. C doesn't have anything. We're going to get that in just a second. What goes with D? Y. Connect D and Y. And then once we get the next one, you would also connect that. That is how you find center of dilation. Where do they all cross at? And what point is that? 0, 12. Does that make sense? Connect the ones that go together. How do I find this missing part here? Find the proportion. This right here. I always like to go to the horizontal and vertical lines. Those are the easier ones. This goes 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. This one goes 1, 2, 3. So then what's it going to do? How do I find the other one? If this is 3 and this is 6, what's it doing? Reducing by, no, by half. Yeah, I get what you're saying. So what am I going to do with this 4? Half of that is 2. Where is point Z at? Did y'all get 8? 3, 8? 3, 8. You have to make sure it is proportional. And then if you wanted to, you connect C and Z and it should go through the same thing. What questions do I have? All right, you are going to glue this on to page 36. Glue this on to page 36. And then for the rest of class, which is about 15 minutes, you can start and hopefully finish your Schoology assignment. This homework is due before you walk in tomorrow.